Looks like we really have a lot of attendees here already from almost everywhere. I see from Africa, I see from the States, I see from Germany. So it's all over the world already. And I'm proud to present something for all the UI makers. And we are going to look into issues that you easily can run into if you execute code just so, and you wonder why your UI is not being responsive anymore. So that's what we're going to see today from my side. All right, so let me start my presentation. Our studio is pretty new, so I will have to figure out how to share my screen. And here we go. All right, I'll turn off my camera so that you will see my screen only and we don't run into any performance issues here on the streaming front end. And here we go. So Ian, ping me if you don't see my starting screen, and I will just start with my session. All right, so my name is Olaf Monien. Ian already introduced me. I'm a long-term MVP of Embarcaderos, and I'm the CEO of Developer Experts. I do consulting on Delphi projects, or not just Delphi projects, but projects where Delphi might be involved with. You can reach me at any time at my email address, olaf@monien.net. And I only have one slide. Well, I have a title, of course. It's all about threads, and we will look into how to get your UI being more responsive by using background threads. And this is my only slide. Everything I'll tell you is done in coding here. So threads, or what? A few terms to talk about first, and this is the first important thing to understand is the UI is single-threaded. That means it's not a Delphi or Embarcadero limitation or something. Basically, all major operating systems, be it on desktop or mobile, are usually single-threaded. That means there's just a single thread that is responsible for rendering all the UI interaction and what's going on the UI. So if you have a screen and there are a couple of edits and they are blinking and whatever, it's all running in one single thread. Okay, and like I said, it's a common thing between major operating systems. There are possibly some specialized systems that might have a multi-threaded UI. So this would be a completely different animal to program against. But here in Delphi, Windows, Mac OS, iOS, Android, and even Linux, it's all single thread. Important. And all the user interaction. So if you create a great looking UI and there's a button on the UI, or not just a single button, but there may be even hundreds of buttons. I've seen those applications where a single form has more than 100 buttons. Not easy to operate, but well, sometimes you will see that. Every single on-click event that you have on a button, or actually the code behind, will run in that very same thread that your UI actually renders in. So if the result of a button click is to disable another control, to load an image, or to display some text, it's all running in that very same thread in the UI thread. And timers. So timers are important to know as well. Every code that you put into a T-timer to run something every second, every 10 seconds, all this code is executed in that very same UI thread as well. So it's all in that UI thread. And the UI thread, maybe you haven't ever heard about that, that's what we also call the main thread. It's the main thread. There are technically more than, or there is technically more than one thread if you just start a blank VCL or FMX application from the object repository in Delphi. it will actually create an application and you run it, and you can look with the task manager or Windows Edit, and you will see there will usually be 3 or 4 threads. There are a couple of threads that do some background stuff, which is not really important here to notice, but there is always a single main thread that every code, like I said, is running in. Important. And that's what we call the main thread. So if you block that main thread by doing something as a response to a button click event, and that runs for several seconds, you are actually blocking the main thread. The UI cannot no longer respond to the operating system to messages like, oh yeah, we are moving around or something, make your UI responsive. That's not going to happen. Your application, or you will just die. I mean, in Windows, you will see something like your UI gets grayed out, and you will finally see a caption saying from Windows, oh, this application is no longer responsive. So that is usually the case when you do some long-running operation from within the main thread. You are blocking the main thread. That's what the ghost window, what these windows in Windows are actually sometimes called, a cause by. You are blocking the main thread. You made the UI no longer respond to Windows messages because you're blocking them. So that's something we have to avoid, or we want to avoid. Of course, in Windows, you can still show something, please wait. Your UI will still look, well, frozen, because you cannot move around Windows anymore. So if you have more than just one main window, all the child windows won't ever move again when you block the main thread. So it's all about blocking, and you are actually dying. So what to do? I mean, sometimes when you browse the internet and you look for solutions to that, you will find advice to use application process messages at a certain point. So every step you take, like you have an on-click event, you're going through a loop, doing something like 100 times, and every 10 times do a application process messages. Well, stay away from that. This is like poor man's multi-threading. It's still everything in the main thread. If your CPU just has a single core, well, you could still argument, okay, that might be even cheaper to use application process messages, but in the end, it makes your whole application, well, more complicated. You lose control. So application process messages is only for certain situations when you really, really want to have your application respond to some messages from Windows at a certain point when you are still blocking the main thread. But in general, you want to stay away from that. Well, the solution is using threads, background threads. A thread different from the main thread. Put all your blocking code into a separate thread. That's the solution. But threads are evil. So just create a thread and expect everything to run just fine. So the disclaimer here is don't implement what I'm showing you today just so. Try to understand, try to find out what it does, play around with it. Don't put that into your production application, in your production project, and roll it out tomorrow. Somebody else might kill you. I mean, really, this is really serious advice. Start playing around with threads and try to understand where they are complicated. They may be evil. Of course, they are technically just a tool, something that you can use. But once you're using threads, be aware. Certain things may happen, and the objects in the rear might be closer than you think they are. So see my code and learn, hopefully, how to survive that. All right. So let's go back to Delphi. And this is Delphi 11.3 Alexandria. It's actually the community edition. I wanted to make sure that everything I'm showing here today is really possible in the community edition as well. The community edition is a free to use version from Embarcadero. It's for hobbyists, for students, for people working on open source software and not making money from it. So there are certain restrictions in the license, so be careful, read through the license, but usually for students, for hobbyists, and for open source programmers, it's free to use. It has a couple of limitations. It doesn't come with source code, and you only have access to local databases. So that's pretty much the technical limitation that you have compared to the enterprise or architect editions that are out in the market. There's also a professional edition, which is feature-wise almost the same like the community edition. The only difference is it comes with source, it comes with a command line compiler, the professional edition, and of course you can use it for any type of commercial project. All right, so I really try to make something simple. So you can easily create applications that have stunning user interfaces using Delphi. You will see that, or you already have seen that yesterday, and you maybe you will see that today, even in further with more in-depth knowledge here. So though I try to keep this simple, this is a FireMonkey application. It's all about recipes and searching recipes from a database. So let's have a quick look what the application actually does. So I'm running that without the debugger for a quick test here. And this is a recipe search application. I really didn't try to make the UI any fancy. Of course, you should clean up the user interface when starting it. So you can type in here, for example, BU, nothing happens. I type another R, and it comes up with suggestions for a recipe or for recipes. So there is a database behind, and that database has a recipe for a burger and for burger buns. So let's select the burger. It loads an image. It knows the title, and here you have some really simple description how to prepare a burger. I didn't try to make that really look fancy. Of course, you can work with HTML, whatever, make that better formatted, whatever. It's really just trying to show how to connect to a database, pull some data off the database, and visualize it. If you are interested in the actual data, of course, I will send the demo database to Ian, so he will provide that as a download. And what you can do is actually go to apilayer.com, and there is a Spoonecular API, and I took the recipes from there. This API is actually owned by Idera, so the company that owns Embarcadero, so it's all family business here. And I actually only took 2 recipes from that database to keep everything simple. Okay, so just in case you're interested how or where to get some ideas for recipes. Okay, we're going back to the application. It's really that simple. So I can type in burger again, and I get burger buns, and it switches to the burger buns. Of course, if I type in bun, it only lists burger buns. So what do we have UI-wise here? We have, well, just a label, an image, a memo. Memo is, of course, scrollable. The whole form is, of course, scalable. And I have a autocomplete or auto search edit field here. It's really just a t-edit, and I used a simple trick how to display this list of suggestions what recipe to use or to display. So let's have a quick look at the application, how to design it. All right, so this is the application. It's only a single form, and it only has the main form. I'm connecting to a database. The database is in SQLite, so it's a file-based database. You can easily try that at home. You don't need to install anything besides Delphi, of course. And here is my database. It's recipes.SQLite. I'm using FireDAC drivers here. FireDAC is the standard database layer or framework in Delphi. And we have a query. The query component is, of course, connected to the connection. And here we have a simple SQL query, which selects everything from recipes that, or where the title meets a certain search text. The search text looks like this here. So this is just an example to make it work in the designer. It's we have the percent sign, burger percent. And we just execute here just to make sure the the SQL query works. Okay, that's fine. And what I did here is I added the all the fields from the query, just 4 fields. It's really, really simple. Let's have a quick look at the database. So here in Delphi, there's a data explorer, and you can select between FireDAC and DB Express here. I have SQLite. I created a shortcut to the recipes that has tables, only a single table. And we can just say view, and this is everything here. So it's ID field, there is a title, burger buns and burgers, and somewhere at the end, there is the instruction field, and we have a blob field that takes the image. This is really a simple design. Of course, we can talk about where to store a blob. Is that wise to put it into the database and everything? Here, for a single user, be it desktop or mobile application where everything is, well, in one executable and one database file, you can easily put that image into a blob field. I know these discussions where they say, well, it's better to put the images into the file system. Of course, you can do that. But here, for simplicity, it works fine. And SQLite is capable enough to take not just 2 images, it will easily digest thousands and more than thousands of images or blob fields in its database format. It's really capable enough. The limits of SQLite are somewhere at 150 terabytes. Don't nail me on that. It's somewhere in that area. So pretty much room in the database to store blobs if you want. So that's the technical aspects of the database. And then let's see how the UI works. This is a T-edit. You see that over here, it's a T-edit. So I can type in here. It has text prompts. This is the gray text. And if you wonder why is the text that large, I didn't use the text settings. So the font is all standard. What I do in these type of applications where I just want a little bit of a bolder, a little bit larger text, I don't change the standard font. What I do is I'm using in FireMonkey, that's something you can only do in FireMonkey, not in the VCL. I use the scaling. So all the controls here, or most of the controls, not the image, all the controls are scaled by the factor of 1.4. That makes your UI look a little bit larger without directly manipulating the font sizes. That means if the default font is already at, let's say, 16 points because somebody chose to do so, you are not actually making it smaller if you change it from default, or assuming a default of 12 and you set it to 14. So I'm using the scaling for that purpose here. So that works pretty fine, especially if you are running the same application on mobile devices. Okay, so the edit is stacked to the top or aligned to the top. The label is aligned to the top. So it's all using alignments here. And then we have a layout. In the layout, it's also aligned to the top, and we have an image in the layout. And then downstairs, there's a client aligned memo, which is read-only. So this is where we're gonna display all the text. I didn't use visual live bindings here. which I could have done, of course. It would be easy and fast and basically just like, I don't know, 10 clicks to connect the controls to my database or the fields in my database and make everything codeless. I wanted, of course, to be able to see what happens where and when, because we are going to play with threads in a moment. Okay, so simple user interface. There is one control that I forgot to talk about, and that is the T list view. It's set to visible false because it won't be visible at the beginning. So when you start typing in the edit, at a certain point, it will turn on the list view, and of course, it will position it correctly. So let's look how to get the coding done here. So there is a single event that I have, and it's the on key up in the edit for the search text. So we have edit search key up. This event will fire every time you press a key and release the key. So once you release a key, it will fire that event. And there I just referenced show matching recipes. So here is show matching recipes. The first thing we do is, in case the query is still open, close it. Then trim the search text, the text that the user entered, and put it into a variable. Then make sure the user entered at least 3 characters. So we are looking for that. And then we attach the wildcards, the percent signs, to make sure the database will look even inside the title. So you saw that I can look for bun, and it will find burger buns. So it will look in the whole text of the title field. And then we set the parameter down here, and we open the query. So if the search text matches any results, we will have a record count of larger than 0. So if there are no matching records, we will keep the list of results invisible, visible false. In case there are actually results, we will walk through the results and apply the text and the image and everything to the UI. So we bring up the list of results. That's the drop down, which I manually created from a T-list view. I tell it to get to the front, just in case another control is trying to render above it. So, and then of course I clear all the items that are still possibly showing. And then that's where the actual work starts. I am going through the results of the recipe query. Here we go. Yes.
Olaf, could you just zoom your code up a little bit? Just zoom the font.
Oh, yeah. Nobody raised the hand, so
fine, because I've got a fantastic monitor, but a couple of people saying they couldn't see it that clearly. And
I hope this is better. I totally forgot that. It's a fresh new VM. I forgot that.
It's great.
Thanks for notifying me. All right. So, great. So we are in the loop that processes all the results in the query. So I told you, or showed you actually, I only have 2 records in the database to keep things simple. And for every record, I add an item to the list view. That's what I'm doing here. And then there is a text and a detailed property in that item of the list view. In the case you have never worked with a list view, just look at the list view and let's make it visible for a moment, just to give you an idea how it looks like at design time, and bring it to the front. There we go. Let me see. Oh, it refuses to show here for whatever reason. Okay. Here we go. So this is basically a template-driven control. So you see there is a header text, there is an item text, there's a footer text, and here is an image. And in the properties of the TList view, you can actually turn on which items you want to see. I don't want to see, of course, I don't want to see the delete button, which is somewhere at the end, at the right end here. We cannot see it right now. It's somewhere turned off at these at the control level here. And I only want the image and the item text, and I turn that on in list view, and we have a property for that, and it's the item appearance. That is the most important property of the TList view, and I turned it to be an image list item. So I have an image and just a single list item. Okay. So we can move that around here a little bit so it doesn't block everything else. Here we go. And let's go back to the source code. So I put in the title of the recipe, the instructions of the recipe, and then, well, I have to work with the image, which is done here. I'm creating a temporary image stream, or actually a memory stream. I save the blob, which is in the database. This is the blob field, the Q recipes image field. That's the field that carries the image. I save it to the stream, and the stream is the memory stream. And the item, the list view item that I just created, has a bitmap property. And here I can say load from stream, and that's relatively easy to load it here, and it will show up as we have seen. Okay, so don't forget the Q recipes .next. If you forget that one, you can watch the memory of your VMware, which is, in my case, it's a virtual machine. You can see how the memory goes up, and at a certain point you will get out of memory exception, because you will have a never-ending loop here. Okay, so don't forget that, and we will walk through the 2 records that we actually have at maximum here, and it will fill up everything. So we have seen that works pretty neat. So again, all this code that I'm doing here is running as a response to the onKeyUp event of the search edit. So if I type in burger, or just Berg, it will do just that. So it works, and I can just click here, and it's actually the second event that I implement. I claimed I only have one single event here. It's actually 2 events. So I can click on that, and it will put everything into the actual detail views. This is all running in the main thread, in the UI thread. How do we know that there is a main thread? Let's have a quick look. We can go to View debug windows, and there is threads. And here is my running application. And like I told you, there may be more than just a single thread. These other threads that you see here are, well, call them maintenance threads, that are doing something deep down in the RTL or in the FireMonkey archives. They keep everything going, and it's something you don't usually work with. There is only one of these threads, is the actual main thread. How to figure out which one is it? So, well, easy, just set a breakpoint here. And we type in a single letter, and we, of course, will sit at the recipe close line. And now you can see this top thread here is apparently the main thread. It is usually the first in the list of threads down here. I don't know if that is really always true, but you can only be safe saying this is the main thread if you have a breakpoint here, and it will stop at the thread that executes that single line of code here. So this is the main thread, and this thread will never change. So if we go through the loop here, and set another breakpoint. We remember the thread ID, which is 6324. I didn't enter more than 2 letters. Let's remove the breakpoint at the top here and enter, oops, and make something useful and put in the other breakpoint again. Okay, so I am in the processing of the result of the query, and it's always, so let's run through it. It should occur 2 times. It's always the same thread. So this is the main thread, and that thread is currently blocked. This is the reason why Windows can't even bring up back the UI, because the thread that runs the UI is now blocked, and that's the reason why you cannot really bring it back here. I'm trying to click on it, it doesn't come back. What you see here is basically a snapshot of the latest state of the UI. So I just minimized Delphi, and that basically makes it appear, but this window is frozen. So because we are holding that thread even, so nothing is happening here. Okay, so far so good. I mean, that works fine. Yes, it does. But what if this query is not really running on a local file database, but a remote database, or even a REST service? I didn't want to explain how to connect to a REST service. That's something for a different session. But what if the recipes are actually coming from, let's say, from this Spuniacula API? And if you look here, down here, there is a recipe. It's a burger recipe. I took that one. I tried that. Oops, what's that? And if we go down here to the recipe information where the actual images are, and if I put in, oops, I killed the demo. Here we go. So let's go back here. Where am I? Oh, we are in the food search still. And let's go down here and put in, no, that's the invitation link. It didn't take my, let's still run the burger query. So this is only returning the titles and an ID, not more. So copy that ID, go to the detail information, paste the ID here, and set include nutrition to true, and run that. Why am I trying to show that? Because it takes quite a while, and we are only pulling a single recipe. So if we had to bring up the images for, let's say, 3, 5, or 4 or 5 recipe suggestions, we would have to run this API call 3, 4, 5 times. And you see, it's really, really slow. It takes time to complete. Okay, so like I said, I didn't want to show and explain how to connect to a REST API. That takes its time, and it's enough stuff for another session. But we will simulate that. So I have a second project. I don't want to damage the first demo. It's actually just a duplicate of the first one that we just walked through. It's the same code, but it has a little difference that I already put in, and this is here. I actually only put in a simulator for a slower responding database. Like you've seen, the API might respond slow, and I'm simulating that with sleep 300. So it's sleeping for 300 milliseconds, which doesn't seem to be too much, but let me show the effect. That's the only difference to the original code. So let's run this and see what happens. Okay, so I'm typing now, burger something. It doesn't respond anymore. You see, I can't really type anymore. I managed to put in burger. I already, you see, there are delays and it's somehow not responding correctly anymore, because just because the 300 milliseconds of the whole query, and it's just 300 milliseconds. This query is pulling everything from images to or from title over instructions to images. And you have seen in the actual API, we would have to call the API one time per matching title. So 300 milliseconds is still a really short amount of time. If we put that up to 1000, just a second, because we have 5 matches and every match takes like 2 to 300 milliseconds to complete, you will see your UI will basically become unusable. We can just take a quick look here. And here we go. Burger. It doesn't respond anymore. And here we go. So it takes time. It's of course a simulation, but you see the effect of it. Okay. All right, so what to do about that? Well, threads. There are 2 ways, or well, at least 2 ways to do threads. You can start with a T-thread class and implement everything. That is usually, well, or requires usually quite some efforts. It's not bad or something. I'm not trying to pull you away from using T-thread. Everything is actually based on T-thread. What I'm going to show you is basically something that makes the usage of T-thread a little bit more easy. So we are going to use another unit. It's system threading. And that system threading comes with something called T-task. So what is slow down here? Slow is basically that. So let's start. T-task run procedure. I will just type something and explain what I'm doing. So I basically entered a, oops, there's a typo. So I basically put the code that I already had into a, oops, something is wrong with my keyboard. Hang on, here we go. So I put everything I had here into an anonymous method. This anonymous method here, this is the anonymous method because it doesn't have a name. And I put this method into a T-task run. T-task run creates a thread or takes a thread from pool, actually. There's a thread pool behind. It takes a thread and executes the code that is written in that anonymous thread method and executes that code in the context of a different thread, in that background thread that T-task creates or pulls from the pool. So this code will now no longer run in the main UI. Well, great, that's what we wanted, possibly. So let me prove that this code is actually not running in the main thread anymore. So I'm just typing something, and here we are. And we go back to the threads, and let's have a quick look at the thread. And you see, this is the current thread, and the thread even has a name. So it's obviously a thread taken from some T thread pool, worker queue thread, whatever, number 1. So it's the first thread taken from a pool. So like I promised, the code here is running now in a background thread. But Would this code actually be sufficient yet? No, of course not. I don't even try to run it any further. So this code now runs in the background, and this means this actual command, this is the only command that we have here when we come from search tag equals something here. This is a single command, and this command will return immediately. So it will return even before this code has executed. There's even no guarantee it will ever execute if you want. So this next line down here will execute most likely before the query even has completed. So that makes no sense, of course. So let's take away this this end and put that down here. So we need the query to complete before we can actually work with the results of the query. Okay, fine. So let's find the correct position for the end call. Oops, that's here. Let's reformat. Let me see if I got it correctly. Let me see. Oh, it's actually wrong. It goes here. Here we go. So let's move that a little bit in here. So now everything from here to here is running in a background thread. Okay, fine. But there is a rule, an important rule. Never forget that. Otherwise, you will miserably die or your application will die. Really. Never ever access anything from the UI, meaning edits, any control, any memo, any TList view, nothing that is in some way managed by the UI. Never ever access that from another thread than the main thread. What are we doing here? Well, quite a lot. This list results visible false is now running or executed from within a background thread. Okay, not good. So what do we do? Well, thread synchronize. Put in a null. Don't ask me why. It's just, well, I know why, but don't ask why. It's just the way it is. Procedure begin end. So we have to work through the code that we have down here. So we follow this path of execution. How we call that. So it's an if then else, something running in the background, and then we are accessing something from the UI, and we have to protect that. We have to put that back into the main thread. This is basically the instruction to block that background thread and execute the next lines, this line of code, in the context of the main thread, and wait until it's completed. Well, this is easy here. This is just a single line. If there are no results, then just turn it off and we're good. So this is more going to be more important over here. So again, I just do some copy and paste here. Oops. So we are accessing the UI again, and we put that into a synchronization block. And again, we are inside a loop that is accessing something which is not exposed to the UI. Okay, fine. So we need to put that again into the back into the main thread, and that ends here. So basically every single line is now manipulating the UI. So that's why I'm putting that into a synchronized call again. So we are going back to the main thread here, and with every single step that we are navigating through the the results of the query, we are putting back control to the main UI. And the main effect is that we put the call that causes the delay, the actual delay, into a main thread. So let's see if that works. Hopefully I didn't put in too many typos here. And I type burger and it responds. Okay, so these are the points where you have to be careful, of course. So let's put in a break. How to deal with that? Let's go to the point where it basically broke. So I do have the loop that goes through the query, and it works with it. And I have something that works with the query up here, and the query is being closed somewhere else. It's being closed here. So we are actually opening the query outside of the we are actually opening the query inside the a background thread, but we are closing it possibly outside of the background thread, which is of course not a good idea, right? And we might have running multiple threads. I mean, what if the first call to the REST API takes 300 milliseconds and another one takes 3000 milliseconds? So we might have multiple pending calls to the database or to the to a REST API, which means that we are conflicting or may have conflicting calls from multiple threads to the same query, which is not good, of course. Right? So what is the solution for that? Well, we have everything down here in the T-task run. Okay? So the complicated stuff is all in here. By nature, if you are doing a or if you are calling or using something like a query or even a REST call, which is relying on a central connection, always use a single instance per thread. So what we have to do is basically to create the query and the connection inside that thread, okay? So this is something where it gets complicated and where when you start doing threads, easily stumble about your own feet, right? So let me try to show how to do that really quick. Okay. I'm gonna use some dirty trick here. I take this one in the clipboard, paste that here. And what I do now is the following. var L connection TFD connection. Okay. So next L connection equals TFD connection. Oops. Create. Well. Okay. So, and next is L connection params and put that in here. And put that in here. Oops. Oh, we make it a little bit different. Like that. L connection params driver ID equals SQLite. So I'm basically creating a connection in code. Login prompt, something we need to turn off, L connection. We don't need that one. Here we go. And we need to create the queue recipes again, L query. You get the idea, I guess. Here we go. And let me take that one as well. Here we go. L query declared as a variable, TFD query. Here we go. Put in the SQL text. L query connection. That is, of course, L connection. Oops. And the SQL text. Here we go. Text. Just a little bit of text manipulation.
Just to let you know, we're actually going to run out of time, Olaf.
Yeah, I'll try to be quick.
Yeah.
Let me get the idea done. That is something we don't need. And now just take Control-Shift-J and modify queue recipes to be L query so that we have a matching name here. And that is pretty much it. The only thing that should be done, I'm not doing right now because of time constraints. Of course, you need to free and null, or at least free the query and the connection components. That should be done at the very end. That should hopefully be all. Almost. Yep. There is one single thing I forgot. And we go down here. And of course, it's not queue recipes titled, but L query field by name. This is now because we don't have persistent fields. Title. Oops. That is And let me just copy and paste that. That's the instructions. There we go. And the last thing would be the image. Image. This is actually a blob field. That should do, I believe. Yeah. There we go. And here we go. So it doesn't block anymore. It's responsive, and it does exactly what I promised to do. Sorry for the quick run at the very last minutes. I hope it will give you some ideas on threading. But like I said, be careful. You see, you can easily run in miserable failures by accessing queries and connections and REST connections from more than one thread. So put every connection into its own thread, or otherwise you will run into errors. Well, thank you for that. I'm sorry again for being overtime a little bit, but hopefully this was a useful session, and I'm of course happy if you have questions. And well, because of time constraint, just send questions to my email address that you have seen previously. Thank you.
Well, that was perfect. I know it ran a bit long, but you know what? I think it was absolutely worth it. You got a lot of questions, and I'm going to actually start the next session a little bit later, just so we can talk to you for a couple of minutes.
All right.
If that's okay by you, you can. I'd put your camera on and keep talking. We can hear you.
Yeah, sure.
There you go, Martha. Can you make it? There you go. See, Martha's so good. She always knows exactly what to do. So there were a lot of questions about things like, is there a way? Oh, this one, it was a bit of a jumbled question, but I think I understood what they're saying. Is there a way of working with T-task and T-thread inside of code without declarations, and that works in earlier versions of Delphi, e.g. 10.2?
Without declarations, I'm not really sure what does the.
What they mean. I think what they mean is this, actually.
Oh yeah. Okay.
Yeah.
T-thread create anonymous thread is a completely different. Well, not completely, but it's a different thing than T-task. T-task, everything you do with T-task is pulling threads from a thread pool, and there is a pool manager behind. That means that manager or that thread manager looks at the current performance of your system. If CPU utilization is at 90%, it won't give you another thread. It will wait until CPU utilization is down to something smaller. That's a standard. It's somewhere not really hard coded. You can change it, but it will try to keep your UI responsive by keeping a few percent of the main system available for the main thread. That's the idea behind T-task and the pool. Create anonymous thread creates just a thread. If you run it in a loop for 1,000 times, you will get 1,000 threads. If you run, or if you put in T-task run into a loop 1,000 times, it will probably create only just like, well, 8 or 16, depending on the course that you have. So, well, if you have one of these fancy AMDs, you might get a few hundred threads. But it will look at the available resources and will try to keep your system responsive. Because, of course, even if you put things into a background thread, that only keeps the UI thread responsive if there is actual time to execute or to run the main thread, you know.
See, this is exactly why I said let's get some questions answered, even though we're running a little bit long, because you know, I mean, people don't know, but I know Olaf pretty well. We chat away on Skype and things like that. We won't talk about the whole, you know, Star Trek thing.
Yeah,
but Olaf is one of these. I've said this a couple of times already, but some of the developers we have on here, I know personally, in terms of what their capabilities are, and Olaf is very much one of those people who's extremely smart and very well respected by his peers amongst other MVPs. And when people have got something really, really tricky, Olaf is the one that comes along and has the answers, and we all go, "Oh, that's the answer." Yes,
well,
of
sometimes.
course. Yeah, well, not always. Yeah, I mean, sometimes we come up with a few answers as well. But you know, it's always a pleasure to talk to you, and your session was extremely popular. Lot of questions being asked and things like that, and also everybody in the private chat is extremely impressed that you did it live as well. We all think you're either brave or completely crazy.
I mean, of course, it's like when you do things live, you easily run out of time because you spend too much time at the very beginning. That always happens to me, and it's a mess that we had that COVID thing, because that means 3 years with no physical events and everything. So, so you know,
yeah, exactly. You're out of training for the live moment. That's what it is. Yeah, I get it. Yeah,
right.
Well, anyway, thanks very much for your session. I really appreciate it, and we'll see you again another time, I'm sure. Okay. All right then.
Thank you.
The next